In this lesson, we are going to look at the entire stoichiometry flowchart, where we have size A and we have size B. And we notice side A and side B have the same unit. The only difference is the letter A and B. What is the letter A and B? The letter A and B are basically the chemicals. In some cases, we have different chemicals and we convert to different chemicals. We have to use the whole entire flowchart. That is, the letter A is always representing the given chemical. Now, because we are using two different chemicals, a new letter is introduced to us, which is the letter B. So B will always representing the unknown chemical, given that we will now working with two different chemicals. But if we only work with one chemical, we don't have to worry about B at all. So keep that in mind. We only use B when we have two different chemicals based on our given and our unknown. So let's go back and look at one problem together. In this case, we have a chemical equation below describe a chemical reaction. So here we have a chemical equation is balanced already and is describing a chemical reaction between nitrogen gas and oxygen gas. That's why we have the G in parentheses. Those are the state of matters. So this is the state of matter for N2 and this is the state of matter for O2. And in this chemical reaction, it absorbs energy. You can see the energy is on the reaction side to produce nitrogen monoxide, which is NO. And nitrogen monoxide is also in the gaseous form. Now for the question, basically it says at standard temperature and pressure, STP. This standard temperature and pressure allows us to use the volume on the flowchart. So right there, only at STP. If it's not at STP, you cannot use this conversion factor. So the question asks how many liters of nitrogen monoxide, or NO, gas are produced from reacting 37.0 grams of O2 and an excess amount of nitrogen gas. So in this case, we know right away it's asking for how many liters of NO, so that tells you that is our unknown. So liter of NO. And our given is 37 grams of oxygen, which is O2. And notice how I copied the chemical exactly as given to us in the problem. And you can see right away we are now working with two different chemicals. So if we look back in terms of solving this problem with steps, the first step is basically identify the given and the unknown. Step 2 is probably one of the most challenging and the most difficult part of this problem. That is, we follow and copy from the flowchart. So what do I mean by that? We had to go back and look at this format right here. That is, we have our unknown and we have our given. That is, if we look at this format, we have the unknown equal the given time, the conversion factor, until we get the unknown unit. So we can think of this, the unknown is where we end, and the given is where we start. And if we look back at the flowchart carefully, it mentioned right there, we start at our given, specifically at the boxes, and we end at our unknown. And the arrows represent the conversion factor. So before I move to step 2, I'm going to go back to my problem, find my given and the unknown, and set up in this format. So my unknown is liter of NO. And my given is 37.0 grams of O2. And that's it. So let's go back to step 2. It's a follow and copy from the flowchart. In this case, if we follow the flowchart, we start from the given. So where is the given, which is defined by the unit grams and the chemical O2. And again, we always start on size A, so we're looking for gram. And gram is a unit mass, so this is where we start. So after we know where we start, we need to look for where are we going to end. In this case, we are going to stop at liter of NO. And you notice NO is not the same thing as O2. That tells you we are using two different chemicals. So for the liter, we're not going to look at size A anymore, but we are going to look at size B. Because A is our given, B is our unknown when we have two different chemicals. And again, B is our unknown chemicals, and A is our given. Since the chemical of the unknown is different than the chemical of the given, we are looking for leaders on the B side. So in this case, this is leader right there. So this is where we're going to end. So that means we are going down, going across, and going down. So this is our first conversion factors right here. This is our second conversion factor right there. And lastly, this is our third conversion factor. So in this case, we have used 3 different conversion factors. So again, we start from here, go across, and down. This is our first conversion factor. This is our second conversion factor. And this is lastly our third conversion factor. So for step 2, we follow the flowchart. Now we just have to copy from the flowchart. So the first conversion factor is 1 moles of A equal to the number of grams of A. We're done with that one. Now we go to the second one, which is number of mole A equal to the number of mole B. And the second conversion factor is number of mole A equal to the number of mole B. We're done with the second conversion factor. Now we're going down. Lastly, we have the last conversion factor, 1 moles of B equal to 22.4 liter of B. So this is the last part of step 2. That is, we copy directly from the flowchart. Now, let's look at step 3. Step 3 basically says substitute in the conversion factor. For step 3, we are going to substitute in the conversion factor. If we look at the conversion factor, which is copy, we have letter A and letter B, and some of the conversion factor do not have number. So therefore, we have to substitute in or find those number. For step 3, we substitute in the conversion factor. Basically, if we look at the conversion factor that we just copied, they are in terms of letter A and letter B, and some of them do not have the number. So we have to find what they are. First of all, we go back and look at this, and we know that A is always the given chemical, so the given chemical is O2. So I'm going to look for all the A and put O2 right next to it. And I substitute in A equal to O2. That's easy. And B is the unknown chemical, so in this case, every time I see B, I put NO. That's easy. So let's go back and look at the number. First of all, how do I get the number of grams of O2? This is something you learned a long time ago, and that is we need to find the molar mass of O2. And O2 has 2 oxygen, so we take 2 times 16, and 16 is the molar mass of oxygen right there, as you can see right there. Right, 16. This is the molar mass of 1 oxygen. But based on our flowchart, we have 2. So that's why we take 2 times 16.00. That gives us 32.00. So therefore, this number is 32.00. Now we are done with this conversion factor because we have all the number and we have the chemical. Let's move on to the next conversion factor. It says number of moles A, which in this case we know is oxygen, equal to number of moles B, which is NO. So we go back to our flowchart. It actually gives us the ideas of where do we get those numbers. We either get from the coefficient or the subscript. In most cases, the coefficient is coming from the chemical equation, and for the subscript, it's usually come from the chemical formula. And if we look at the problem again, we don't have a chemical formula as a whole thing. We have multiple chemical formula that describe the chemical equation. So we have a chemical equation overall. So we are going to use a coefficient, which is the number in front of the chemical formula. So we look at it. Here we have oxygen right there. And oxygen, the coefficient for oxygen is, oh wait a minute, we don't have any. So we know it's going to be 1. So that number right there is going to be 1. And for NO is right there, we know that NO is right here. It has a coefficient of 2, so we know that it's 2. And that's it. That's all we have to do for that conversion factor. Now let's move on to the next conversion factor. Notice how I pretty much don't have to read the problem again. We just have to substitute in the conversion factor. That's the whole idea of step 3. And lastly, we're on the last conversion factor. It has a number, it has a chemical and a unit, it has a number, it has a unit and a chemical. And we don't have to do anything about it. And now we are done with step 3. Let's go to step 4. How about that? That was pretty easy, isn't it? Step 4 is even easier. That is, we multiply as a fraction. Because these are now in conversion factor. Can we multiply this as fraction? And step 4 is probably the easiest part of all. That is, we just have to rewrite as in terms of fraction. So first of all, we have 37.0 gram of O2. Then we times the first conversion factor, which is that one. Notice how the conversion factor has two sides, right? One on this side and the other one on that side. And they have different units. So in this case, we have mole and gram. And we look at this one, we have gram. And we want to cancel out, so the gram must be on the bottom. So that's why we have 32.00 gram of O2 on the bottom. If this side is on the bottom, the leftover part must be on top, because we don't have two locations to put. So 1 mole of O2 is going to be on top. And we are done with this conversion factor. Notice how grams of O2 cancel out. Then we look at the next conversion factor. We can ignore this one and that one as well. Now we focus on that one. Note how this is mole of O2. Again, we have two sides. So the side with a mole of O2 will be on the bottom again, because we want to cancel out exactly how many? 1 mole of O2. Since the moles of O2 is on the bottom, the other side must be on top, which is 2 moles of NO. And we are done with this conversion factors. Now do you see how easy step 4 is? We just have to rewrite as a fraction. And then lastly, this conversion factor. We can now ignore the other one. In this case, it is moles of NO, therefore the side with moles of NO is going to be on the bottom. So we have 1 mole of NO. If this side is on the bottom, the other side must be on top, which is 22.4 liter of NO. And we can check your answer. Notice how this is the same thing as our no. Then now we can go back and cancel out unit and chemical. Moles of O2 cancel moles of O2. Moles of NO equal cancel out with moles of NO. And we just have to multiply everything on top, divide everything on the bottom. So we have 37.0 times 1, which we can ignore, times 2 times 22.4 liter of NO. And divide everything on the bottom, which in this case, we have 32 times 1 times 1, and we can ignore those 1. So we have 32.00. This is our answer. If we look at the solution, we notice it has many conversion factors involved. However, if we follow all of these steps, it is extremely easy. The most important step is step number 2. You follow and copy the flowchart very carefully.